Hi all. Today we'll be discussing the LeetCode problem of the day. Divide an array into subarrays with min cost. So here you're given an array of length n, and the cost of an array is defined as the first element of the array. So for example, if you have the array 1, 2, 3, so the cost of this array is equal to the first element, which is 1. And similarly, if you see this array, the array is 3, 4, 1. So the cost will be the first element, which is 3. So you're given a large array and you have to split this array into three disjoint contiguous subarrays. So you need to split it into three subarrays, and the cost of this is equal to sum of the cost of each subarrays. If we take a big example, suppose we have 7, 4, 8, 7, 6. So this is the array. Suppose let's say I divide it into three parts. First part will be, let's say, 7, 4, 1. The second part is 2, 8. And the last part is 7, 6. So cost of this first part will be the first element of this subarray, which is 7. And similarly for this array, it will be 2. And for this array, it will be 7. So if you add all of them, you will get it as 16. So this is one way of doing it. And if you do it, you get the sum as 16. So among all the possible ways, you need to return the minimum possible sum that you can achieve to split the array into three subarrays. So if you look at the examples, in the first array you have 1, 2, 3, 12. So we can split the array into three subarrays as follows. So first subarray will contain only 1, and then second subarray will contain only 2, and the last subarray will contain 3 and 12. So cost of this will be 1, cost of the next subarray will be 2, and cost of this will be 3. So if you add it, you'll get the total sum as 6, and that is the least sum you can achieve for this input. Now coming to the second example, here you only have three elements, so each of the element will be a separate subarray, and the cost will be simply 5 plus 4 plus 3, which is 12. And finally, let's come check the last example, 10, 3, 1, and 1. So to split this, you can first choose this as your first subarray, then 1 as the next subarray, and the last will be also 1. And in this example, your sum will be 10 for this subarray. For this, you get it as 1, and same for this also 1. So total sum will be 10 plus 1 plus 1, which will be 12. So your output as 12. Coming to the constraints, the array size will be at least 3 and at most 50, and all the numbers in the array will be from 1 to 50. Now let's go the approach. So suppose you have a long array and your objective is to split this into three subarrays. So one thing we can see is the first subarray will always start with the first index. So let me use a different color. So let's say first subarray will start at index 0 and it is ending somewhere here. And then obviously the next subarray will start here, the same index, and it will go up to some index. And finally the last subarray as well, it will start where the second subarray has ended, and it will go until the last of the array. So by this we have split the array into three subarrays at some random points. So now if you want to see the sum, so for the first subarray, the sum will be exactly equal to the first element of the original array, which is nums of 0. Now for the second subarray and third subarray, you can pick the points at any positions. Apart from the first element, in the rest of the array, you can choose to pick at any two random spots. And since you want to minimize the total sum, so in the rest of the array, you just need to pick the two smallest elements, and that will be your answer. So suppose this value is let's say 2, and here you have a value, sorry, yeah, here you have 2, and here you have a 1, and remaining all numbers are like huge, maybe 5, 10, 15, and all big numbers. So once you choose two smallest elements in this in the rest of the array, your answer will be this value, nums of 0 plus 2 plus 1. So the question comes down to be you just need to find the minimum 2 elements in the array from index 1 to the rest of the array. Now let's quickly code the approach. So leaving the first index, you have to iterate on the array from index 1 to the rest of the array to find the first two smallest elements. So for that, let me just take two variables. Let's say first min1. And initially, since we are trying to minimize the number, we'll assign it with the maximum value possible. Integer dot max value. And similarly, you can take it for min2 variable also. So now let's start iterating. So here, note that you will start iterating from index 1 because, okay, let me first draw this array. Yeah. So the first element, which is nums of 0, will be included in our first subarray and it will end somewhere. And for the rest of the two elements, we need to iterate in the rest of the array to find the first two smallest elements. So by looking at this example, the first two smallest elements would be 2 and 3. So let's see in one iteration how we can find both the first smallest element and the second smallest element in the rest of the array. So yeah, initially both min1 and min2 are defined as infinite value. So first step, if your current number nums of I is less than equal to your min1. So if you find a number which is less than min1, then of course you can update your min1. So min1 will be nums of I. Also, before doing this, so one thing we can see is min1 is the first minimum least value in the array, and min2 will be the second least value in the array. So min1 will always be less than equal to min2. So here we see that we found a better value which is less than min1. So before updating that value in min1, so whatever value we have in minimum 1, we will first set it into minimum 2. So min2 will be equal to min1. And then the minimum 1 will be updated to the new smallest value we have found it. So if this is not true, then we'll also check for the min2 case. Else if nums of I is less than min2. So if it's less than equal to min2, then we can directly update min2 equal to nums of I. So I'll just do a dry run on this example. So this process will be a bit more clear. So once we are done with the for loop, we'll get the two smallest elements, which will be in the variables min1 and min2. So at the end, you can just return nums of 0 plus min1 plus min2. We test it. Yeah, it works. So before submitting it, I just want to do a quick dry run on this. Okay, so let me just copy the array once more. And we have two variables, initially min1 and min2. So before starting the loop, both are assigned as infinite value. So I'll just update the same thing. So now we are starting from index I equal to 1. So you are at I equal to 1. So 4 is less than min1. So min1 was infinity and you found a better value for the min1. So you will set min1 equal to 4. Also before doing this, you will set min2 equal to min1. So initially min1 and min2 are infinite. So the min2 doesn't change. So after first iteration, you have found the minimum value, the first minimum value in this part of the array, which is 4. After that, you are at 8. So when you're at 8, you'll first check if your current number 8 is less than equal to min1 or not. So 8 is not less than 4. So you won't update min1. But at the same time, you'll also try to check with min2 as well. So your current value, which is 8, it is less than equal to infinite. So you can update your min2 to be 8. So we can see in this part of the array, the first smallest value is 4 and the second smallest value is 8. And that's what your variables are defining. Next, when you're at 6, the first if condition fails because 6 is not less than equal to 4. Then in the next statement, you will see 6 is less than equal to min2. So min2 was 8. You found a better value 6. So you'll update your min2 to be 6. And we can see in this part of the array, the first smallest value is 4 and the second smallest value is 6. Now you're at 3. So here we'll see how this is working. So 3 is less than equal to min1. So you found a better value. So you'll update your min1 to be 3. But also before updating your min1 to be 3, the current min1, which is 4, you will set it to min2. So that means first you will set min2 as 4. And then for the min1, you will update your new smallest value that you have found. So let's see what is happening. So in this array, we can see the smallest value is 3, and that is what's stored in min1. And the second smallest value is 4, and that is what is stored in min2. So that's why we first update min2 is equal to min1 before updating the new smallest value for min1. Then after this, your value is 9. So 9 is not less than min1, and also 9 is not less than min2, so you skip it. Next, you're at 3. So when you're at 3, the 3 is less than equal to the min1. So again, min2, you can update it as min1. So now, because of this, the min2 is also 3. And min1 will be 3 as well, because it's same, so no point in updating. In the next iteration as well, you have a 3. So 3 is less than equal to 3. So min2 is also 3, min1 is also 3. So nothing changes here as well. Next, you're at 5. 5 is less than equal to 3, it fails, and 5 is less than equal to min2 as well, this also fails, so you skip it. Finally, when you're at 2, you'll see that num1 is less than min1. So 2 is less than equal to 3, so you'll update min1 to be 2. But also before doing this, you'll set your min2 is equal to min1. So this is already 3, so it doesn't matter. Next, when you're at 8, it is not less than equal to 2, and it is also not less than equal to 3, so you skip it. So once you iterate on the whole array, you see that min1 holds 2 and min2 holds 3, and that is what the two smallest elements in this array are. 2 is the first smallest element, and after that you get a 3. So the 3 can be whatever you can choose. So if you just want to see what is your actual subarray with these values, yeah, so the first you see that the first value is 7, and you got your min1 as 2 and your min2 as 3. So from 7, you can have this as your first subarray, and from this 3 to maybe this 5, you can have your second subarray, and from 2, you can have your last subarray. So these are your 3 subarrays, and your answer will be 7 plus 3 plus 2. So yeah, let me just submit it now. Yeah, and it works. Finally, let's do the time and space complexity analysis. So coming to the time complexity, we are just iterating on the array once. So it will be simply order of n. And coming to the space complexity, we are not using any extra space. We are just using 2 variables to show the min1 and min2 and just the iterator for the I. So space is also constant. So we can just use it as order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.